the first thing you want to do whenever you see a graph on an AP Calculus test is determine what that is the graph of, because it's not always the same graph, right? So here we're looking at the graph of f prime. This is the graph of the derivative. Then, based upon that graph, they want us to determine which of the following statements is true. And so this is the AP Calculus people's way of kind of making us go through 5 little smaller problems instead of just doing it as 5 separate problems. So we got to kind of go through all of our answers and see if it's true or not. So A is saying that the derivative does not exist at x equals 0 and x equals 2. Well, if I look at this, this is the graph of the derivative. And if it was not going to exist, I would want to see holes in the graph at x equals 0 and x equals 2, because that's what it would mean for this derivative graph to not have a value. Well, I can see that at 0, I do have a dot there, and at x equals 2, I do have a dot there. So the derivative does exist at those points. If they had said to us the second derivative does not exist, that's what it would mean when we go to take this information in, because reading the derivative off of this graph, we would see that the second derivative would be does not exist at those points. But the graph is of the derivative function, and the derivative function does have values there. We can see that there are not holes, there are actual dots. So that is not a true statement. Moving on to B now, B is telling us that f, the original function, is decreasing on these two intervals there. Well, remember, you're not looking at the actual graph, you are looking at the graph of the derivative. So to determine if the original graph is increasing or decreasing, we have to read our first derivative information off of there. Reading our derivative graph, wherever the derivative is up in the positive, that's where our original function is increasing. Wherever our graph would be down in the negative, that's where our original function is decreasing. So if f is decreasing on these intervals, we need the graph of the derivative, which is what we're looking at, to all be down in the negative. Well, we can see that between -2 and 0, it is not down in the negative, and it is also not down in the negative between 2 and 4. So that is not going to work for us. Moving on to C now, C is saying that f has a point of inflection, an inflection point at x equals 0 and x equals 2. So we need to know what an inflection point, what is the definition of an inflection point? What has to happen for that to be true? Well, two things have to happen to have an inflection point. The first is you need the second derivative to equal 0 at that point, or you need the second derivative to be undefined at that point. The second thing you have to be on the lookout for, the second thing that must absolutely happen, is that it must change concavity. Just having the first thing up here be true doesn't give you an inflection point. You need to make sure that it also changes concavity. The graph needs to change from being concave up into concave down, or it needs to change from being concave down into concave up. And so what that tells us is if it changes concavity and it has a second derivative of 0 or undefined, we know we're looking at an inflection point. Well, then to find out this information, we need to be able to read off the second derivative data from our first derivative graph, which really means you're going to be reading off the derivative, right? So we're not reading off concavity off of this graph, we're reading the derivative of this graph, and that's going to tell us second derivative information. So when you're reading the derivative of a graph, wherever the graph is headed up, that's a positive slope and a positive derivative value. Wherever the graph is headed down, that's a negative slope and a negative derivative value. And wherever it goes horizontal, that's a 0 slope and a 0 derivative value. And in this situation, because we're starting at the first derivative graph and reading off second derivative information, wherever this graph is positive slope would tell us that it's concave up. Wherever it's got a negative slope is going to tell us where this thing would be concave down. And then wherever it would have a 0 or an undefined slope, that's going to tell us where we have a possible inflection point. So we come through and we read off this data. So starting off here, the graph is headed down and going negative. And then we hit that place where they told us at x equals 0, it is undefined. So at x equals 0, we know that this would be a possible inflection point because it's undefined there. And then it goes up, so that would be positive slopes, positive second derivative data. And then at the top here, that's the other place at x equals 2 where it is undefined. So that's another possible inflection point. And then what's happening on the other side there is it's all going negative. So then what it's saying is this section here where it's negative is concave down. This section here where it's negative is concave down because we're reading off second derivative data. And this section here where it's positive, it's concave up. So looking at the two places they care about, at x equals 0, we have that it is undefined. And then to the left of it, it's concave down. And to the right of it, it's concave up. So then it also fits the second criteria, it's changing concavity. So that is a definite inflection point. Then looking at x equals 2, it fits again the first quality, which it is undefined there. They told us that in this situation. It's also got a sharp corner. You know we don't have derivatives at sharp corners like that. And it goes from concave up to concave down. So it also changes concavity and fits the second requirement of an inflection point. And so now we know that both 0 and 2 are inflection points. And so this is absolutely true. Answer C. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.